Assalamualaikum and a very good morning to all of you. Today, we from Group 6 we present the element of Group 15 in the periodic table. Firstly, I will introduce my group member, which is Nur Asila Shafika, Nurul Ashikin, and me, Nur Atika. In this presentation, we will explain about the scientific and common name of element, symbol of element, source, element history, physical properties, chemical properties, reaction, application of element, and effect towards environment including plants, animals, and humans. Group 15 elements are also called nitrogen family, include nitrogen, phosphorus, arsenic, antimony, and bismuth element. The p block elements are also known as the representative element, which is placed on the right side of the main periodic table. The modern periodic table, as conceived by Dmitry Mendeleev, arranged all the elements known to humans on the basis of its atomic number, which is unique to every element. The result of such an arrangement were the periodic table. The elements with similar properties were arranged into a column called group. In group 15, we starting with the lightest element, which is nitrogen, and finishing with the heavy element, which is bismuth. We notice a general flow in properties as we move down the order. Nitrogen was discovered by Daniel Rutherford in 1772. The name is derived from the Greek nitron and genus meaning nitriforme. Nitrogen made up 78% of the air by volume and obtained by distillation of liquid air. The history of nitrogen is nitrogen in the form of ammonium chloride was known to the alchemist as salt ammonia. Manufactured in Egypt, heating a mixture of tongue, salt, and urine. Nitrogen gas itself was obtained in the 1760 by both Henry Cavendish and Joseph Priestley. The first person to suggest this was an element in young student Daniel Rutherford in his doctorate thesis of September 1772 at Edinburgh, Scotland. The second element is phosphorus. Phosphorus is discovered by Honeybrand in 1669. The name is derived from the Greek phosphorus meaning bringer of light. Phosphorus is widely found in compound in minerals. Phosphate rock is found in large quantities in the USA and elsewhere. The history of phosphorus first made by Honeybrand at Homer in 1669, where he evaporated urine and heated the residue until it was red hot, where open phosphoric vapor distillate, which he collected by condensing it in water. The third element is arsenic. Arsenic was discovered by Albertus Magnus in approx 1250. The name is thought to come from arsenicon, the Greek name for the yellow pigment alpinum. A small amount of arsenic is found in its native state. It is mainly found in minerals. The history of arsenic. Arsenic was known to the ancient Egyptians and is mentioned in one papyrus as a way of killing metal. The Greek philosopher Theophrastus knew of two arsenic sulfate minerals, which is orpiment and virga. The Chinese also know about arsenic as the writing of Pentas or Kanmu. He compiled his great work on the natural world in the 1500 during the Ming Dynasty. He noted the toxicity associated with arsenic compounds and mentioned their use as pesticide in rice fields. For the next element is antimony. Antimony was discovered by Nicholas Flammery in 1654 until 1715 for the first studies and discovered in approximately 1600 BC. The origin of the name is derived from the Greek antimonous, meaning not alone. The antimony found in small quantities in over 100 mineral species. It is most often found as antimony trisulfide, and antimony can also be found as the native metal. The history of antimony is antimony and its compound were known to the ancients, and there is a 5,000 years old antimony vase in the Louvre in Paris. Antimony sulfate is mentioned in an Egyptian papyrus of the 16th century BC. The black form of this pigment, which occurs naturally as the mineral stibnite, was used as mascara and known as coal. The most famous user was the temptress Jezebel, whose exploits are recorded in Bible. The last element in Group 15 is bismuth. Bismuth is discovered by Georges Agricola in early 1500. Claude Francois Geoffroy was proved in 1753, but the discovery date of bismuth is approximately 1500. The origin of the name of bismuth is from the German "Bismutum", a corruption of "Erzmesse", meaning white mess. The source of bismuth is native metal and in ores such as bismuth cyanide and bismuth, byproduct of refining lead, copper, tin, silver, and gold ores. The history of bismuth is bismuth was discovered by an unknown alchemist around 1400 AD. Later that century it was alloyed with lead to make cast type for printer and decorated caskets which been crafted in the metal. Bismuth was often confused with lead. It was likewise a heavy metal and melted at a relatively low temperature made it easy to work. Georges Agricola, in early of 1500, speculated that it was a distinctly different metal, as did Caspar Neumann in the early 1700, but proved that it was so finally calm in 1753 thanks to the work of Claude Francois Geoffroy. Now, we go to the physical properties of group 15 element. Firstly, group 15 elements exhibit very physical properties due to their valence shared electron configuration with completely filling s orbital and half filling p orbital. Nitrogen is a diatomic gas and the rest of elements are solid in nature. Nitrogen and phosphorus are non-metal in nature, while arsenic and antimony are metalloids. Bismuth is the heaviest known radioactive metal in the periodic table. Likewise, as we go down the group, the density of element increases. As we go down the group, the mean energy level also increases. As new orbitals are added with increasing atomic number, the valence electrons move further away from nucleus, making the atomic radius to increase. The covalent radius increased drastically from nitrogen to phosphorus. However, from arsenic to bismuth, only a small increase in ionic radius is noticed. This happens because of the presence of completely filled d orbital and f orbital in the heavier element. With increasing nuclear size, the melting point and boiling point also increase. Also, nitrogen has a very low melting and boiling point because it occurs as a diatomic gas with two atoms bonded together in triple bond. The diatomic particles stay away from each other, and because of their discrete nature, the intermolecular space is small. Note that the melting point increases from nitrogen to arsenic and then it starts decreasing. This happens because even though this element has a layered structure, due to valence electrons further away from the nucleus, the particles can freely press into each other. Also, the boiling point of bismuth is not more than antimony because of the low packing of atoms in a metallic bond.
Chemical properties in group 50. In this topic, we will learn about reaction equations occur in element group 15. There are 5 reactions in this topic, such as oxidation state, reaction with hydrogen, reaction with oxygen, reaction with halogen, and reaction with metal. Oxidation state. What do we mean by oxidation state? Oxidation state is the total number of electrons that an atom either gains or loses in order to form a chemical bond with another atom. Conceptually, the oxidation state may be positive, negative, or zero. Okay, let's take a look at oxidation state in element group 15. The element of group 15 generally exhibit negative 3, positive 3, and positive 5 oxidation state. The tendency to exhibit negative 3 oxidation state decreases as we move down the group due to an increase in the size of the atom and the metallic character. In fact, the stability of the positive 5 state also decreases as we move down the group. Due to the inner path effect, the stability of positive 5 state decreases and positive 3 state increases as we move down the group in the periodic table. What is inner pair effect? Inner pair effect is reluctance of an s2 electron to take part in bonding due to the force shielding effect of intervening d and f orbitals on moving down the group. The inner pair theory was proposed by Sidgwick. Oxidation state in nitrogen. The oxidation state from positive 1 to positive 4 tend to disproportionate in acidic solution. Phosphorus, the intermediate oxidation state disproportionate into positive 5 and negative 3 in both acid and alkalis. Arsenic, antimony, and bismuth, the positive 3 state is stable with respect to disproportionation. Let's take a look reaction with hydrogen. The element of group 50 react with hydrogen to form hydride of type EH3, where E stands for nitrogen, phosphorus, arsenic, antimony, or bismuth. The stability of hydride decreases, moving down the group from NH3 to BiH3. Next, reaction with oxygen. The element of group 15 form two types of oxide, E2O3 and E2O5, where E stands for nitrogen, phosphorus, arsenic, antimony, or bismuth. The oxide with the element in the higher oxidation state is more acidic than the other. However, the acidic character decreases on moving down a group. Nitrogen shows a strong tendency to form p-pi-p-pi bond with oxygen. What is p-pi-p-pi bond? P-pi-p-pi bonds are the bonds that are formed by the overlapping of p orbitals perpendicular to the internuclear axis. When we look in this table, nitrogen forms 5 stable oxides. In oxidation state positive 1, nitrous oxide cure. Positive 2, nitric oxide. Positive 3, dinitrogen trioxide. Positive 4, dinitrogen tetraoxide. Positive 5, dinitrogen pentaoxide. As you know, bismuth can form oxide in positive 5 oxidation state because of the inner pair effect. Oxide in the higher oxidation state of an element are more acidic than of the lower oxidation state. Hence, the acidic strength of oxide of nitrogen increases from N2O3 to N2O5. Next section with halogen. The group 15 elements react with halogen to form two series of salts, EX3 and EX5. However, nitrogen does not form NX5 as it lacks the d orbital. All three halides except NH3 are stable. All the elements of group 15 form trihalide and pentahalide. Pentahalides are more prevalent than trihalides because the elements in higher oxidation states have more polarizing power. Next, reaction with metal. The group 15 element react with metal to form binary compound in which metal exhibit negative 3 oxidation state with the general formula M3E2. M stands for metal while E stands for an element of group 15. For example, calcium nitrate, calcium phosphide, and etc. When we look at the equation, 3M plus 2E produce binary compound. 3 calcium plus nitrogen produce calcium nitrate. 6 calcium plus phosphorus produce calcium phosphide. 6 zinc plus 4 antimony produce zinc antimonide. 6 magnesium plus 4 bismuth produce magnesium bismuthide. Okay, we're moving to application of element of group 15. First, we look at application of nitrogen. Nitrogen used for fertilizer in agriculture, pressurized gas for oil, refrigerant, explosive, metal treatment, or protection. In application of phosphorus, phosphorus used for manufacture of phosphoric acid H3PO4. The phosphorus found in soft drink, used in matches and firewood, and used for medicine. Next is application of arsenic. Arsenic used for compound and weed killer, used as a poison, used as rodenticide. Next is application of antimony. Antimony used in alloys, used in semiconductor industry, and used in battery. Last but not least, application of bismuth. Bismuth is used in medication and as a catalyst. Lastly is application of moscovium. Moscovium is used in scientific study and used to make nihonium. Nihonium is from group 13.
Environmental effect including animals, plants, and humans of element group 15. Humans have radically changed natural supplies of nitrates and nitrates. The main cause of the addition of nitrates and nitrates is the extensive use of fertilizer. Combustion process can also enhance the nitrate and nitrate supplies due to the emissions of nitrogen oxide that can be converted to nitrates and nitrates in the environment. Nitrates and nitrates also form during chemical production and they are used as a food conserver. This causes groundwater and surface water nitrogen concentration and nitrogen in food to increase greatly. The addition of nitrogen bond in the environment has various effects. Firstly, it can change the compositions of species due to susceptibility of certain organisms to the consequence. Another effect of phosphorus. Too much phosphorus can cause increased growth of algae and large aquatic plants, which can result in decreased levels of dissolved oxygen, a process called eutrophication. High levels of phosphorus can also lead to algae blooms that produce algal toxin, which can be harmful to human and animal health. Too much phosphate can cause health problems such as kidney damage and osteoporosis. Phosphate shortage can also occur. These are caused by extensive use of medicine. White phosphorus. White phosphorus burns in air and causes severe burns upon contact with skin or eyes. White phosphorus will also cause eye and respiratory tract irritation. Other initial adverse health effects are primarily due to gastrointestinal irritation. Environmental impact of arsenic. Exposure to inorganic arsenic can cause various health effects such as irritation of the stomach and intestine, decreased production of red and white blood cells, skin change, and lung irritation. It can also intensify the change of cancer development, especially the change of development of skin cancer, lung cancer, liver cancer, and lymphatic cancer. A very high exposure to inorganic arsenic can cause infertility and miscarriage for pregnant women, and it can cause skin disturbance, decline resistance to infection, heart disruption, and brain damage with both men and women. And also, inorganic arsenic can also damage DNA. But for organic arsenic, neither can cause cancer nor DNA damage, but exposure to high doses may cause certain effects to human health, such as nerve injury and stomach. The concentration of the dangerous inorganic arsenic that are currently present in surface water enhances the chance of alteration of genetic material of fish. This is mainly caused by accumulation of arsenic in the bodies of plants eating freshwater organisms. Birds eat the fish that already contain eminent amount of arsenic and will die as a result of arsenic poisoning as fish is decomposed in their bodies. Environmental effect of antimony can cause irritation of the eyes, skin, and lungs to humans. As the exposure continues, more serious health effects may occur, such as lung disease, heart problems, diarrhea, severe vomiting, and stomach ulcers. High levels of antimony may kill small animals, such as rats, may experience lung, heart, liver, and kidney damage year to day. Animals that breathe in low levels of antimony for a long
time may experience eyes irritations, hair loss, and lung damage. Dogs may experience heart problems even when they are exposed to low levels of antimony. Animals that breathe in low levels of antimony for a couple of months may also experience fertility problems. Environmental effect of bismuth. Bismuth and its salt can cause kidney damage. The route of entry is by inhalation, skin, and injections. Inhalations poison may be a noxious dust causing respiratory irritation, may cause cold breath, metallic taste, and gingivitis. Gingivitis is a common problem. Injections by poison. Injections poison may cause nausea, loss of appetite, and weight. Malaise, albuminuria, diarrhea, skin reactions, stomatitis, headache, fever, sickness, depression, rheumatic pain, and black line may form on gums in the mouth due to depositions of bismuth sulfide. That's all from our group. Thank you.